Hello folks, I just wanted to make another video that was a short recap of graphing sine and cosine. I know the first time you learn it, it can be kind of overwhelming dealing with all those radian values and actually substituting them in and seeing where they hit to graph the curves. But this, will kind of give you the meat and potatoes of the whole idea, if you will. So let's recall the most important thing about a periodic function for you to understand. We can just say a periodic function repeats itself over and over again. Most importantly, hitting the same exact y values. Hitting the same exact y values. Okay, that's the idea of a periodic function. Let's stretch this out. There we go. Okay, so a period. Let me actually write this out for you. A period is how long it takes. To complete one cycle. A period is how long it takes to complete one cycle. So what I want to do is I'm going to give you a couple of different graphs, and I want you to tell me if they are periodic. Okay, this first graph, we'll just put 4 up here. Let's put 5. And then let's go ahead and count by tens. So 10, 20, 30, 40, 50, 60. And let's label the evens. And there's 70. So if a graph looks like this, it's at 0, 0, it is defined. And it goes up here. The next point is going to be 20, 5 with an open circle there. Drops back down again to 20. Goes back up to 40 with an open circle. Open coordinates. Closed coordinate down at 40, 0. Open here. Let's do one more. Let's do 80. Here. So my question to you is this, and you could write the question if you want, but it'll basically be straightforward. Is this function here periodic? Well, first of all, is it a function, right? And the answer is yes, because it passes the vertical line test. The second thing is this function periodic? Does it repeat itself over and over again, hitting the same exact y values? And the answer is yes, right? Every 0 to 20 and the next 20 and the next 20 will always hit the same exact y values. In fact, these pieces look the same no matter what part of the graph they are on. So the question is it a function? Yes. My next question is, what is the period? How long does it take to get through one cycle? So in this case, each of those periods is 20. It takes 20 units on the x-axis to get through one cycle. I wonder if it'll let me move this without messing anything else up. Sure, kind of. No, it kind of messes one up. Okay, I'll do the other one over here. Okay, so if this graph looks like this, let's count up 4 on the y-axis. And then just count by 2's on the x-axis. And this one will be a step function, which we've seen before. So let's say it starts here at 0, 1, and then it goes over to 2 with an open coordinate, jumps up to 2, goes over to 4, jumps up to 3, goes over to 6, jumps up to 4, goes over to 8. Now my scale doesn't look lovely because I did not draw them very spaced out appropriately, but you get the idea. So the question is this periodic? And if so, what is the period? At first glance, it may look periodic because it looks like it's doing the same thing over and over and over again. But again, I want to go back to the definition of periodic. Notice that it has to hit the same exact y values. So this function would look different if I took a snapshot of it at the x values from 100 to 120, right? The y values would be much greater. So this one is not considered periodic. Even though it looks repetitive, there are different y values that are hit depending on which part of the graph you're looking at. Different y values. Okay, so that's the basics on periodic. Now, just to recap how to graph sine and cosine in a way that might be a little bit more straightforward than filling out the x and y chart every single time. The main thing that I need you to remember with sine and cosine is that we care about the four corners. We care about four corners. Meaning, that word looks kind of weird. Meaning, if you just can remember your coordinates for 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then of course 360 is the same, then you can graph sine and cosine no problem. Remember that your y's, your max and your min are at 1 and -1. So again, your four corners, if this is y is equal to the sine, sometimes you'll see it as the sine of x. Sometimes you might see it as y is equal to the sine of theta, right? Because theta typically deals with our radians. So again, let's just do four corners. The first one, if we're starting from standard position, is 0. The next one is going to be pi over 2, right? Straight upward. The next one is going to be sorry, that was bothering me. There we go. The next one's going to be over to the left at pi. The next one's going to be, oh, I wonder if someone's at the door. 3 pi over 2, and then the last full revolution will be 2 pi. So at the four corners, remember, sine is dealing with the y value. So at the initial standard position, the y value there is 0. We rotate up to, and you know, even if you need to, just draw your little unit circle like this, right? This coordinate is 1, 0. This one is 0, 1. This one's -1, 0, 0, -1. So at pi over 2, the y value is 1. At pi, it's down at 0. At 3 pi over 2, it's down to -1. And at 2 pi, it is back to 0. So there is your sine function very quickly. And then you can always go through those points and put arrows to show that it occurs over and over and over again. So there's the sine function. The cosine function, we're going to do the same idea, only worrying about those four corners there. So if we have y equals cosine of x, or again, you might see it written as y is equal to the cosine of theta. Our min and our max values on the y-axis are -1 and 1. And on the x-axis, did I just say x-axis twice? Maybe. Our four corners, pi over 2, pi, 3 pi over 2, and 2 pi. So cosine deals with the x value. If I look at the x value at those four coordinates starting in standard position, I start at 1. That's the main difference between sine and cosine. Cosine starts at 1. And then the wave just continues as predicted. Up at pi over 2, it's at 0. At pi, it's down to -1. At 3 pi over 2, it's at 0. And at 2 pi, it is back up to +1. And again, you can draw through it and put arrows to show that it goes on forever. So that's the quicker way to be able to sketch sine and cosine, is just worry about those four main coordinates. You don't have to worry about those square root of 2 over 2, which is that 0.707 in between to estimate. Okay, so I just want to do one example that shows you, like what if I change the period on you, right? What if I want a different snapshot? So what if I asked you to graph the sine of theta, but just for this given domain between 5 pi and 10 pi? Okay, so what I want to do here, let me stretch this out. What I want to do here is I want to graph the sine function, except I only want to graph it between 5 pi and 10 pi. So I don't want to start at 0, right? I want to start closer to 5 pi. So nothing else is changing with my graph except for where am I looking at it. So my y values are still going to be at -1 for a min and at +1 for a max. And then what you can do is to show that your graph is going to start or it's going to skip some stuff, so to speak. You put this little squiggly there. It's mathematically, what's the word I'm looking for? Preferred if you're going to skip some numbers in between. Like, so if you need values from 100 to 120, you don't need to start all the way at 0. Same thing here. If I'm starting at 5 pi, I don't need 0. Let me start at the value that I need. Let me start at 5 pi. And then you can do your big pi. So let's do 5. We need to go all the way up to 10. So 5, 6. Actually, let's do this to 9. I apologize. Let's change this to 9 pi. We don't need to go that far. Okay, so that's 5 pi, 6 pi, 7 pi, 8 pi, and 9 pi. Okay, so the key is this. You need to figure out, there's not much to it, right? Your values are either going to be 0, -1, or +1. So you can figure out where is 5 pi on the unit circle. So you can spend the time finding for a reference angle. So let's write down our choices. Choices. Choice number 1 is use unit circle to find, that word is neither of what I was just said. Use unit circle to find a reference angle for each of these. Okay. Number 2 is plug values in to calculator. Make sure you're in radian mode. Okay, radian mode. So what I mean by that is if you like I said, your values are only going to be -1, 0, and +1, which means if you plug 5 pi in the calculator, so let's do that. We're doing sine. So again, hit the mode button. If your calculator's not in radian mode, make sure you highlight it, hit enter, and then second quit. So then if you literally type into your calculator, let me write my workout here to the side. If I type in the sine of 5 pi, just like my screen looks here, then you get 0. So you know it's going to hit there. So then type in the sine of 6 pi. It's 2e -13. That's what mine says. Okay, guess what that means? If it says something weird like that, that means it is 2 times 10 to the -13th power, which is essentially 0. What about sine of 7 pi? Mine now says 4e to the -13th power, which is again 0. Sine of 8 pi, another one of those weird things, which is 0. And then sine of 9 pi, 2 times 10 to the -13th power, which is again 0. So sometimes it's not going to tell you 0. It's going to tell you that weird, long, scientific notation number. That's essentially 0. The trick here is realize that all of my points are 0, so I need something else. I need points in the middle of these pies. So you can write out, you can put your little tick mark. So you got to figure out what these are to be able to plug them into the calculator. So between 5 pi and 6 pi, so this is technically 10 pi over 2, right? Because 10 over 2 is 5, which means this one would be 11 pi over 2. And if this is 12 pi over 2, then this one would be 13 pi over 2. So let's plug those into the calculator now. And then if I plug in sine of 11 pi over 2, sine of 11 pi over 2, you get -1. So that helps us. That's telling us at this point, our curve comes down here first. And then hopefully, when we do the sine of 13 pi over 2, it's going to be up at +1, which it is. Sorry, 13 pi over 2. I think I just said over 1. So this is equal to +1. And then from here, everything is pretty much predictable. You can know that the next one will come down here, the next one will go up there, and there's your sine wave just from 5 pi to 9 pi. So again, you can go ahead and use your calculator to assist you with those values, or kind of go back to the basics by using the unit circle to find your reference angle first, and then what the values should be.